Yesterday we discussed about the molar conductance and equivalent conductance also we discussed here. Okay, so what is the formula for the molar conductance, Javian? Molar conductance is equal to lambda m is
Lambda m is equal to K into 1000 by M.
1000 by m. Okay,
M.
and what is the equivalent conductance? What is the formula we are using to calculate the equivalent conductance?
So it is lambda EQ is equal to K into 1000 by M.
Okay, so lambda EQ is equal to K into 1000 divided by n. Okay,
N.
so what are the units? Means units also clearly I mentioned here. For the equivalent conductance,
Yes, sir.
the units means ohm inverse, centimeter inverse, and equivalent inverse. So because of sometimes to make you confused in examination also they're asking the question based on the units also. Okay.
Yes,
Yeah.
sir.
Then next, molar conductance and equivalent conductance. And what are the factors affecting the conductance or conductivity? Okay, so what are the factors affecting the conductance? Okay, so let us see now. Here, so what are the factors affecting the conductance? So this is a little bit one more important concept we are having here. Okay, factors affecting the conductance. Factors affecting conductance. Factors affecting conductance. Okay, here. So we have a different types. So one is what are the factors going to be affect the conductance means here. One is nature of electrolyte. Nature of electrolyte. So because of we have a strong electrolytes and weak electrolytes. So which are having the high conductance means strong electrolytes are having high conductance while comparing with the weak electrolyte. So that's why conductance is depends upon the nature of the electrolyte. And second one is nature of the solvent. This point also already we discussed here. So nature of solvent. Okay, so what is the second one means here? Nature of the solvent. What is the solvent we are using means water. Okay, so when the electrolyte is dissolved in a water means it acts as a good conductor of the electricity. Clear? Next, temperature. Next, temperature. So what is another concept we are having means here? Temperature. Okay, so temperature. So third one is concentration of the electrolyte. Fourth one is concentration of electrolyte. Concentration of electrolyte. Okay, so these are the different factors affecting the conductance. Okay, now in this one, first one we can check it out the concentration of the electrolyte. Okay, so here we have a specific conductivity. Okay, so conductivity is different and conductance also different. So conductance is nothing but the substance which allows the flow of electric current is called as a conductance. And what is meant by the conductivity? Okay, so conductivity means here what is the relationship between the concentration and conductivity means here conductivity is decreases by increasing concentration of electrolyte. Okay, concentration of electrolyte. So because of conductivity is nothing but specific conductance. So this we are going to represent with as a kappa here. So conductivity is specific conductance is decreases by increasing of the concentration of the electrolyte. Okay, sir, how it is decreases? Actually, what happen means here conductance is depends upon the number of ions in a solution. Yeah, so conductance is depends upon mobility of the ions. Conductivity is depends upon and conductance also is depends upon mobility of the ion. Now specific conductivity. In specific conductivity, in a greater the concentration means all the ions are very close together. If ions are very close together, means if they have any mobility, if they can move from one place to another place here, so they cannot be moved from one place to another place. If the mobility is not there, means it does not conduct the electricity. Okay, so now we got the clarity. So due to that reason only, so conductance is going to be decreases by increasing the concentration of the electrolyte. Okay, and molar conductance is going to be increases. Okay, so here based on dilution, molar conductance is going to be increases. Molar conductance, molar conductance is increases. So why the molar conductance is going to be increases means molar conductance is depends upon the number of the ions in a unit volume of the solution. Okay, more number of ions means greater the conductivity. So due to that reason, conductivity decreases by increasing the concentration of the electrolyte, but molar conductance is going to be increases. Okay, so this also we can explain. Molar conductance is explained. So based on the strong electrolytes and weak electrolytes also. Okay, so if you see strong electrolytes are, so what is the example for the strong electrolytes? Here molar conductance and concentration Let us see in this one, if the concentration is going to be increases means here conductivity, molar conductance you will get as a like this here. It is going to get as a gradual decrease. Okay, this side what happened, concentration is going to be increases. This side what happened here, concentration is going to be increases, and this side what happened, molar concentration is going to be increases. Actually you will get like this one. So gradual like it will be there here. Okay, if the sir where we can observe means here, so decreasing of the concentration, this side is represent as a decreasing of the concentration. Gradually it is going to be decreases. Sir, when the concentration is going to be decreases means by addition of the water. In laboratory we use some solution. You remember while doing the practicals, we had seen the dilute solutions and concentrated solution. How we can convert the concentrated solutions into dilute solutions, Jabian?
So by adding water to it,
very good, man.
like
By
dilute
adding,
water.
by adding the water, okay, we can convert the concentrated solutions into so dilute solution. Okay, so similarly, whenever you are adding water to the concentrated solution, okay, in a unit volume of the solution, number of ions are going to be decreases only now. Okay, if the number of ions are going to be decreases means here conductivity also is going to be decreases and molar conductance is going to be increases. Sir, why the molar conductance is going to be increases means ions are freely, they can move from one place to another place. When the ions are they freely moves from one place to another place means here that time molar conductance is going to be increases and conductivity is going to be decreases. Clear? Okay, and sir, we had seen for the strong electrolytes. So what is the graph for this one? This graph is represented as a strong electrolyte. So what is the example of the strong electrolyte means we are taking as a KCl. We are taking as a KCl. KCl is called as a strong electrolyte. So what is the strong electrolyte means here? The substance which it undergoes to the complete dissociation is called as a strong electrolyte. And weak electrolytes are there. Okay, so weak electrolytes, it is partially, gradually, it will come like this here. Okay, they won't get decreased gradually here. Okay, slowly they'll make as a constant. If the dilution is going to be increases, if the dilution is going to be increases means molar conductance is going to be increases. Sir, how you are telling that for weak acids or weak electrolytes, if the dilution is increases, okay, and conductivity is going to be increases means here because of weak electrolytes are partially soluble in a water. If the dilution is going to be increases means their solubility also is going to be increases. If the solubility is going to be increases means number of ions in a unit volume is going to be increases. Then only molar conductance is going to be increases. Now we got the clarity. Okay, and so temperature. So temperature is directly proportional to the conductance of the electrolytes. Conductance of electrolytes. Conductance of electrolytes. Okay, so degree of dissociation is going to be increases. If the degree of dissociation is going to be increases means here their conductance also is going to be increases. So all these are the different factors affecting the conductance. Okay, So based on that one, so what is that? Which one is going to be explained? Conductance of the strong electrolytes, my dear. Okay, so which one is going to be explained? The strong electrolytes means, sorry, weak electrolyte, conductance of the weak electrolytes means here D by Huckel-Onsager equation. Okay, so which one is going to be explained means here D by Huckel-Onsager equation is going to be explained the conductance of the weak electrolytes. Okay, so who's going to explain the molar conductance of the weak electrolyte? Conductance of weak electrolyte is explains based on D by Huckel-Onsager equation. D by Huckel-Onsager equation. D by Huckel-Onsager equation. So what is meant by the D by Huckel-Onsager equation means here lambda m is equal to lambda n naught minus square root of a into square root of c. Okay, in this one, so lambda m naught minus a into square root of c. In this one, what is meant by the lambda m? So lambda m is nothing but molar conductance. Okay, and what is meant by the lambda m naught? So lambda n naught is nothing but molar conductance at infinite dilution. Molar conductance at infinite dilution. In this one, A is nothing but constant. And C is nothing but concentration. Okay. Now, in this one, if you see means, okay. So here, sir, what is mean by the infinite dilution? What is mean the infinite dilution means if keep on adding the water. Okay. If keep on adding the water means at one particular place, the number of ions becomes as 0. Okay. In a solution, the number of ions becomes as a 0. That condition only we can call as a molar conductance at infinite dilution. Sir, for which one it becomes as a 0 means here, for weak electrolytes, number of ions becomes as a 0. Okay. For that one example I'll tell you. Okay. First, better to take as a some of glass of the water. Okay. If you place in that one tablespoon of the sugar. Okay. How much sugar, ma? If you add 1 tablespoon of the sugar in a half glass of the water, then whatever the water taste, it will be very sweet or less sweet it will be that. Sweeta?
Sir, could you repeat the question once more?
So once again, I'm asking the question, ma. First, better to take as a 1 glass of the water, 1 tumbler of the water. Okay, half of the tumbler of the water. Okay, in half of the tumbler of the water, just to place 1 tablespoon of the sugar. 1 tablespoon of the sugar. Then the sugar solution, it becomes as a sweet or less sweet it will be there.
It will not be that sweet.
It will not be that much. If you take small glass means, small tumbler means.
Oh, yeah, then it will be sweet then.
Then it will be sweet here. Okay. Now, better we'll take here. Better directly I'm telling that here. So just you take as some 50 ml of the water. Okay, 50 ml of the water. Or if you take some 100 ml of the water. In 100 ml of the water, if you place 1 tablespoon of the sugar means the sugar solution becomes as a sweet. Is that clear?
Yes, sir.
Okay. Now, for total how much ml of the sugar solution we got? 100 ml of the sugar solution only now. Okay. Whenever you added the 1 tablespoon of the sugar in 100 ml of the water means the sugar solution, it becomes as a sweet in taste. Okay. In that only, first, if you add some 50 ml of the water, the sweetness is going to be increases or decreases?
Decreases.
decreases. First, if you add 50 ml of the water means here sweetness is going to be decreases. Okay. Now again, if you add one more 100 ml of the water, again it is going to be decreases or increases? Sweetness
Decreases.
decreases. Okay, so whenever you're adding, keep on adding the water, sweetness is going to be decreases, and finally at one particular place you won't observe any taste. Is that clear? Is it correct only now? If keep
Yes,
on
sir.
adding the water means you can't find out any taste at one particular place. Okay, so that particular place only we can call as an infinite dilution. Sir, why we can't find out any taste means here? Because of whenever you keep on adding the water, sugar particles becomes very less in the water. Sugar particles are less means automatically sweetness also it becomes as a less. Okay, automatically. So this one sweetness also it becoming as a less. So why what happen means because of number of particles are less. But here also what I'm telling that for concentrated solution, if you keep on adding the water, so finally at one particular place you will get as a number of ions becomes as a zero. Number of ions becomes as a zero. Wherever the number of ions becoming as a zero for the strong electrolytes are anyone here, that is only we can call as a infinite dilution. Okay, but at infinite dilution, molar conductance of the weak electrolytes is different. Sir, how you are telling that molar conductance of the weak electrolytes is different at infinite dilution means because of by increasing the dilution. Okay, so here degree of dissociation of the weak electrolytes is going to be increases. Degree of dissociation of the weak electrolytes is going to be increases. That means number of ions are increases now. For weak electrolytes, every time if you add more water means number of ions are going to be increases. Number of ions are increases means their conductivity also is going to be increases. So based on that one, okay, so which theory is going to be explained? The conductance of the weak electrolyte at infinite dilution means here d by Huckel-Onsager equation. So what is the mathematical expression they had given means here lambda m is equal to lambda naught minus a into square root of c. Okay, in this one. So they're asking one question. So what is the slope in the given equation? According to the d by Huckel-Onsager equation, what is the slope? Any one of you? Any one of you? Any one of you? Ma? What is the slope? Actually, whenever you're drawing the graph, okay, you all are math students only. So what is the formula we can use? Y is equal to mx plus c. Is it right? In this one, so m we are taking on the, that means x-axis, y-axis, this is the x-axis. Y-axis and this one is the x-axis means slope is become as a this one only now. And this one it becomes as an intercept. C it becomes as a intercept. Okay. Now, according to the d by Huckel-Onsager equation also, in this one, so lambda m we are taking on the y-axis. Okay. Square root of t we are taking as a x-axis. Okay. In this one, so here molar conductance of the weak electrolytes is going to be increases. If it is increases means what is the slope here? Slope is nothing but minus a. Slope is nothing but minus a. And what is the intercept means? Intercept is nothing but lambda m naught. Okay, so what is the intercept? Intercept is nothing but here lambda m naught. So based on graphical questions also it is that. If they had given some formula means you had to expect which one is the slope and which one is y-axis, which one is the intercept also. You got the point or not? Okay.
Yes, sir.
So then what is the another important concept we are having means here Kohlrausch law. Okay, so Kohlraasch law. So what is the another important concept we are having? But the JEE level examination means here Kohlraasch law. Okay, so Kohlraasch law. Kohlraasch law here. So what is meant by the Kohlraasch law means here? Kohlraasch law is it explains molar conductance of the weak electrolytes. Okay, it explains molar conductance of weak electrolyte. Molar conductance of weak electrolyte. Okay, so how we can calculate the molar conductance of the weak electrolyte at infinite dilution? At infinite dilution. Okay, so how we can calculate the molar conductance of at an infinite dilution means here, according to the Kohlraasch law, the molar conductance of any electrolyte is equal to sum of the contribution of the individual ions is called as a molar Kohlraasch law method. So what is meant by the Kohlraasch law means here, at a given temperature, okay, at a given temperature, so molar conductance of any electrolyte at infinite dilution is equal to, it is sum of the contribution of the ions present in a solution is called as a Kohlraasch law. For example, what is the molar conductance of the NaCl? What is the molar conductance of the NaCl means here? It is sum of molar conductance of Na plus ion plus molar conductance of Cl minus ion at infinite dilution. Okay, so based on this one, they're asking the questions in the examination part. So, okay, they're asking some questions in the examination part. So, what are the main importance of the Kohlraasch law means here? Kohlraasch law can be used to find out the molar conductance at infinite dilution. That is the one point. What is the second point means here? We can find out the degree of dissociation. We can find out degree of dissociation. Degree of dissociation. So degree of dissociation can be represented with alpha. Sir, how we can find out the degree of dissociation means here molar conductance at concentration divided by, so molar conductance at infinite dilution. Okay, so how we can find out the degree of dissociation means degree of dissociation is equal to, degree of dissociation can be represented with alpha. Alpha is equal to lambda NC. Lambda NC nothing but molar conductance at concentration divided by molar conductance at infinite dilution. So based on this one only, again we can calculate the dissociation constant also. Dissociation constant. Dissociation constant. So what is the formula for the generally dissociation constant means K is equal to C alpha square by 1 minus alpha. If you substitute the alpha value in the above equation means you will get the answer. Okay, so now you got the clarity. So based on these three formulas, we are having some questions. Based on these three formulas, we are having some questions also in the examination part, especially in JEE. Okay, especially in JEE, we have a question also. Okay, and what is the question means? They had given one question, but let us see here. Here, right now, one simple question they had given to make you clarity. I'm giving one question. Okay, what is the question means here? Simple it is there. Calculations and all, it takes time. That's why I'm not doing any calculations. Because of crash course means if you started doing of the calculation means whatever the 40 minutes I'm getting, in that 40 minutes, I can complete only 1 or 2 questions. I can't complete more number of questions. So better I'll forward some assignment. I am forwarding some assignments. Are you solving or not?
Yes, sir.
If you want along with that one key also, if you want key also.
Yeah, sir. Could you post the key?
Okay, so then So today onwards, I'll post the key also to cross check the answers here. Okay, if you cross check your answers means you will get some clarity. Okay, if you're having any doubt means, so please post that question in a group. I will solve and I'll repost in the group also. Okay.
Okay, sir.
Right, ma'am. So simple question, only one simple question I want to give here. Okay, so what is the question they asking means here? Calculate the molar conductance of the calcium chloride. Okay, what is the question they had given means here? Calculate molar conductance of calcium chloride by using following data. So what is the data they had given means? They had given molar conductance of the calcium plus 2 ion is equal to 119 Simon centimeter square and mole inverse. And so they had given molar conductance of Cl minus is equal to 76.3 Simon centimeter square and mole inverse. So any one of you, can you tell me the answer? What is the molar conductance of the calcium chloride? That means we have to calculate lambda not m CaCl2 we have to calculate. So how we can calculate the lambda m not CaCl2 ma? So this is very, very important. In NEET level also compulsory they're asking the questions, and JEE level also they're asking the questions. What is that? Samhita J left. What is the answer, Srita, Javian? First of all, how we can write the formula means here in this one, lambda m naught Ca plus 2 plus 2 into lambda m naught Cl minus. Because of if the calcium chloride is going to be ionized means it forms as a 1 calcium Ca plus 2 and 2 moles of the Cl minus ions. Okay, actually this is the formula. So what is the statement I had given us here? So what is the Kohlraasch law means here? Kohlraasch law is used to calculate the molar conductance of the weak electrolytes at infinite dilution. Okay, so it is equal to sum of the contribution of the individual ions present in a solution is called as a molar conductance. Already they had given us a Ca plus 2 value. What is the Ca plus 2 value? 119 plus, and Cl minus value already they had given in question. That means 2 into 76.3. If we simplify that one means how much we'll get?
Sir, 271.6.
So 271.6 Simon centimeter square mole inverse. Okay, it's the correct answer. So what is the correct answer means here 271.6 Simon centimeter square and mole inverse. Okay, so based on second formula also we're having some questions. Based on some formula also, second formula and third formula also we're having some questions in the JEE level. So once you figure out that question, so okay, clear? This is the main importance of this point. Okay, right. So based on this one also we can explain the ionic mobility. And what is another important concept we're having in this chapter means here? So what are two more important concepts are there? What are the two more important concepts we're having means? One is electrochemical cell. I think so about the electrochemical cell, we already discussed about the redox reaction. Is it right or not?
Yes, sir.
Okay. So I don't want to discuss once again briefly, I'll discuss more. So what is the electrochemical cell means here? The cell which converts the chemical energy into electrical energy is called as a electrochemical cell. Okay. The cell which is convert the chemical energy into electrical energy is called as a electrochemical cell. Electrochemical cell is containing two compartments. Okay. In one compartment, zinc metal is placed in a aqueous solution of the zinc sulfate. In another one, so copper metal is placed in aqueous solution of the copper sulfate. Okay, so these two are connected to the external circuit. These two are connected to the external circuit. In this one is stacked as an anode, another one is stacked as a cathode. Okay, in the electrochemical cell, cathode is having positive charge, anode is having negative charge. Sir, why anode is having negative charge means here, in this one, zinc metal is it undergoes to the oxidation reaction. If it undergoes to the oxidation reaction means it releases the number of electron. Okay, then these electrons are moves from anode to cathode. These electrons are moves from here anode to cathode. That time the current is moves from cathode to anode. Current is moves from cathode to anode. Okay, so these two are we connected with the salt bridge. These two are connected with the salt bridge. So why we are connected with the salt bridge? Inverted U2. Inverted U2 only we can call it as a salt bridge. Okay, the salt bridge is containing agar gel, agar gel. Okay, and KCl, ammonium chloride, NH4, Cl, and potassium nitrate, KNO3. Okay, so this it contains the paste of agar gel, KCl, ammonium chloride, and KNO3 should be there. So what is the main importance of the salt bridge? Means salt bridge is used to maintain electrical neutrality. It is used to maintain electrical neutrality. Okay, salt bridge is used to maintain here electrical neutrality. Okay, in this one, which one is we can call as oxidation of cell and which one we can call as a reduction of cell? Which one we can call as oxidation of cell and which one is we can call as a reduction of cell? Anodic half cell is called as a oxidation half cell, and this one is we can call as a reduction half cell. This one is we can call as a reduction half cell. Okay, in between these two, so in between two half cells we have some potential difference. Okay, in between two half cells we have some potential difference. That potential difference only we can call as here cell potential. That is only we can call as here cell potential. Sir, how we can call as a, how we can calculate the cell potential? Means cell potential is equal to E cathode minus E anode. E cathode minus E anode. This also we can write as here E right minus E left. E right minus E left. That means E right is nothing but the cell which is present at right hand side. E left is nothing but the cell which is present at left hand side. So by using this formula, we can calculate the cell potential value. Okay. So based on this one also, we are having some of the calculation. Based on this one only, we are writing as a Nernst equation also. Okay. You can write as here Nernst equation. So what is the Nernst equation? Do you have any idea about that Nernst equation? Nernst equation, we don't have any theoretical proof. Nernst equation is having only mathematical expression. Nernst equation is having only mathematical expression. Okay. So what is the mathematical expression of the equation? Nernst equation.
Sir, I don't remember.
Didn't remember? Anyone you having idea about that one? So what is the formula we can write for the Nernst equation? It is also very important one. Based on this one also JEE level, they're asking the questions. Okay. So how we can calculate the Nernst equation means here E cell is equal to E naught cell minus, okay, 0.052, so 0.059 divided by n log of here E cathode, sorry, E products by reactants we can write. E product by reactants we can write. Products by reactants we can write. Okay. So another formation also is that actually, so after simplification, I wrote the formula. Actually, what is the full formula means here? E cell is equal to E0 cell minus, okay, so here you will get as a RT by NF 2.303 2.303 log of products by reactant. This also we can write as a oxidized form by reduced form. Oxidized form by reduced form. Oxidized form by reduced form. This is the one more formula which we are having questions in the JEE level examination. Actually, in this one, 2.303, R is nothing but universal gas constant. It is absolute temperature. F is nothing but Faraday. What is the 1 Faraday value? 96,500. Okay. In this one, N is nothing but, what is the N is means here? Number of electrons transferred in a chemical reaction. Number of electrons transferred in a chemical reaction. After substituting all that values, what is the formula we are getting means here? E0 minus 0.059 by N log of product by reaction. Okay, this is the one formula we are using to calculate the E cell value. Okay, sir, E cell also it has a relationship with the free energy. What is meant by the free energy means here? Free energy can be represented with delta G. Okay, delta G gives free energy, we can call. Okay, this we can call as here gives free energy. Okay, so gives free energy also it is having some relationship between the E0 cell. Sir, how we can write the formula gives free energy and E0 cell value means here minus NF E0 cell we can write. Okay, minus NF E0 cell we can write here. Okay, delta G0. Okay, now you take as a E0 means here delta G0 is equal to minus NF E0 cell. This is the one formula. So we have another formula also. So gives you free energy and equilibrium constant also we have a one more formula. Gives you free energy and E0 formula also it is there. Okay, so that means how we can write as means here delta G0 is equal to minus 2.303 RT log of K. K is nothing but equilibrium constant. K is nothing but equilibrium constant. Equilibrium constant. Okay, so by using these formulas, we are having the calculations in the examination part. Okay, along with that one, we have some concept, theoretical concept. So what is the theoretical concept we are having based on this chapter means here batteries are there. Batteries which we are using, we have a different types of the batteries now. Watch batteries are different. Okay, and whatever we are using in mobile, this one mobile battery also is different. Okay, inverter batteries is different. Okay, and Nippo battery and that all we are using. Did you remember? In wall clock, what is the batteries we can use? Wall clock. We have a different companies now. In wall clock.
So those thing, no pencil batteries.
Pencil batteries we can call
Like
that.
Lagrantial batteries.
Lagrantial batteries here. Actually, just I'm talking about the batteries only. In remote also we are using some of the batteries. Nippo batteries, Duracell and all. Okay, so all these are we have a different types of the batteries. Actually, what is meant by the batteries means batteries are the energy sources. All batteries are here energy sources. Okay, so based on that one, we have two types of the batteries. Primary batteries are there and secondary batteries are there. How many batteries are there means we have primary batteries and secondary batteries are there. Sir, which one we can take as a primary batteries means here primary batteries are example of Leclanche cell. Leclanche cell. Okay, Leclanche cell. A Leclanche cell also we can call as here dry cell. Sir, what is the example of the dry cell means here? Whatever the battery we are using in wall clocks, TV remotes, okay, all that are we can call as here. So primary batteries only. Okay, and what is the another one means here? So we can call as a button cell. Button cell. Sir, what is the example of the button cell and what all means here? In watch we are using. In watch we are using some batteries now. Small batteries it will be there. So they will be look like as a very button size. Button size it will be there. So due to that reason only we can call it as a button cells. Okay, dry cell and button cells are examples of the primary batteries. Sir, what is the primary batteries means here? The battery which cannot be reused by the recharging. The batteries cannot be reused. Okay, whatever the batteries, watch battery it is there. Either it is reusable ma. Again we can use here.
No, sir.
Okay, and TV remote batteries and wall clock also, whatever the batteries are that all those are again either it is reusable or they cannot be reusable.
They can't be reusable.
So they cannot be reusable. Simply what we can say means here, all those are we can call as here not rechargeable batteries. Okay, primary cells cannot be rechargeable. They can be use and throw only. Okay, primary batteries cannot be rechargeable. So that batteries only we can call as a primary batteries. And secondary battery. So what is the example of the secondary battery means here? Inverter battery. That is only we can call as a lead acid battery. That is only we can call as a lead acid battery. Okay, lead acid battery. In this one, so how much percentage of the acid we are taking means here 30% of the sulfuric acid. So nowadays everyone they're having the inverters at home. Is it right? In that one, if you see means, so when the chemical that means sulfuric acid is decreased means they're adding as a sulfuric acid. Dilute sulfuric acid is going to be filled in the lead acid battery. Sir, how much percentage of the sulfuric acid they are going to be add means here? They're adding 30% of the sulfuric acid. They're adding 30% of the sulfuric acid. In that one, how they're asking the questions based on these concepts means here, which one is it act as a cathode? Which one is it act as an anode? What is the chemical reaction takes place in a lead acid battery? Okay, by the rechargeable process, what is the reaction? Directly formula based question. So all these formulas we have to by heart only, we don't have any option. Okay, and what is another battery we are having means here? Nickel cadmium battery also it is an example of secondary battery. Nickel cadmium battery also is an example of secondary battery. Okay, and fuel cell one it is that. So where we are using the fuel cell means here astronauts they are using as a fuel cell by using the hydrogen gas and oxygen gas. First we can prepare as a water. After preparing the preparation of the water only, the gases are convert the electrical energy. The gases are converted into the electrical energy. So what is the main importance of the fuel cell means here? By using the fuel cell, we can convert the hydrogen gas and oxygen gas into water as well. They produce the electrical energy. They produce here electrical energy. So where we are using as a fuel cell means fuel cells are they used as astronauts, and fuel cells are they are highly efficient. 70% of efficient. 70% of the efficient, 70% of the substance is converted into the electrical energy, and pollution free also. That does not produce any pollution. So that's why nowadays we are getting as more importance for the fuel cell. Now you got the clarity, all of you? Okay, so this is about the electrochemistry. Okay, so today I'm going to forward some assignment just to practice some questions. If you are having any doubts means we'll discuss. Okay.
Okay, sir.
Right, we'll continue in the next class. Again, I'm having one more class. Okay. Thank you all.
Okay, sir.
Thank you,
Thank you,
sir.
sir.
Samhita, do you understand?
So she's not there, sir.
Okay, right. So we'll continue in the next class. Okay. Thank you,
Thank you,
Jamia.
sir.
Okay, sir. Thank you, sir.